Welcome, shall we observe the sun? The Evershed effect. Solar cycle 25 is producing a lot of sunspots. This is giving amateur astronomers an opportunity they haven't had in years, the chance to look into the dark cores and see what is going on. On April 24, a Dutch astronomer nicknamed Neo did just that, and I observed the Evershed effect, he says. Great seeing conditions allowed me to capture 35 AVs from which I created this animation, says Neo. Attentive viewers can recognize a radial outflow of gas across the sunspot's penumbra. That's the Evershed effect. British astronomer John Evershed discovered this phenomenon in 1909 while he was working at the Kodaikanal Solar Observatory in India. The government of India later made a postage stamp to celebrate it. More than 100 years later, researchers still aren't certain what causes the Evershed effect. A leading theory holds that material is being siphoned out of the sunspot through magnetic flux tubes, much like a milkshake sucked out of a straw. Supermagnetic filament. The biggest thing on the sun today is not a sunspot. It's a supermagnetic filament, says Pepe Mantica, who photographed the structure using a backyard solar telescope in Barcelona, Spain. This filament is huge, it stretches 370,000 kilometers from end to end, about the same as the distance from Earth to the Moon. One end of the filament is attached to sunspot AR3032, the other end is not pinned to anything. Powerful currents of plasma are coursing through the filament, according to NASA's Solar Dynamics Observatory. If the structure becomes unstable and erupts, it could hurl a significant CME away from the Sun. Stay tuned. This solar flare chart shows the last 3 days of flare activity. And as you can see, there have been multiple C-class flares thus far. On this LASCOC2 filter, the CME activity, for the last 2 days can be observed. On the 19th, there have been 2 CME thus far, one at 7:48 Coordinated Universal Time. At a 146-degree angle and the other at 8:12 Coordinated Universal Time. At a 61-degree angle. The solar wind speed is currently moderately high, 551.4 km per second. On this model, the solar pressure on the magnetosphere is showing the high pressure in red for today. These two geoelectric field maps are based on different specifications of the Earth conductivity. The geoelectric field is a measure of the induction hazard to artificial conductors, such as electrical power lines, that results from geomagnetic activity, and can be used to estimate the amount of current induced by integrating along the conducting pathway. The higher concentration of currents are lighter blue, or orange, to red. This is the position of the planets today. And as always, sit back, relax, and let me keep my eye on the sun for you.